The goal of this video is to simplify radicals and multiply radicals. So first we're going to start with a review of simplifying radicals that are perfect square. So when something is a perfect square, that means a number times itself is going to get us the number under the square root. So for example, if I break down 25, remember we break it down to 5 and 5. That gives us a pair where we cross one out. There's nothing left over, so we would just be left with 5. There's no root when we have a perfect square. So in number 2, the square root of 100 is 10, but there's a negative out front, so we have negative 1 times 10, which would be negative 10. Number 3, 2/3 times the square root of 9. Well, the square root of 9 is 3, so we have 2/3 times 3. Threes are going to cancel each other out, and we're left with 2. In number 4, the square root of 100 is 10. We have a 5 on the bottom. 10 divided by 5 is 2. In number 5, we can do this two ways. We can either multiply this together first or take the square roots. Now, knowing that these are both perfect squares, I'm going to just take the square root of each of them first. So the square root of 16 is 4. The square root of 4 is 2. And then I can multiply those together. 4 times 2 would bring us to 8. Number 6, the square root of 25 over the square root of 4. So the square root of 25 is 5. The square root of 4 is 2. And that does not simplify at all. Now, we're not always so lucky that everything's going to be a perfect square. So when it's not a perfect square, for example, if I was to type this in my calculator, the square root of 48 is not a nice whole number. It's going to give us a decimal. So we don't want to write it as a decimal. Instead, we want to make a factor tree to simplify our radical. So we're trying to figure out what are two numbers that multiply to 48. And there's a lot of different combinations you can pick. I'm going to pick 6 and 8. Now, those are not prime numbers because there are different numbers that multiply to them still. So we want to break them down to our prime factor. So two numbers that multiply to 6 are 3 and 2. Then for 8, two numbers that multiply to 8 are 2 and 4. And two numbers that multiply to 4 are 2 and 2. Now we're at prime numbers. And we know it's a prime number because the only numbers that multiply are 1 and itself. So I want to look for pairs. Anywhere that you see a pair, you're going to circle and cross one of those pairs out. The number that's not crossed out is going to come out front in front of the radical. Now, a number that does not have a branch or a partner, so in this case 3, we can underline it if we want. We're going to put that under the square root, so we get 4 root 3. Now, you don't have to underline it. That's just a way to help you see what numbers were left over. I usually prefer not to underline them, so in the next couple of problems, I will not be. What's the square root of 72? So two numbers that multiply to 72 are 9 and 8. 9 breaks down to 3 and 3. 8 breaks down to 4 and 2. 4 breaks down to 2 and 2. So when I look at these, I'm at my prime numbers. I have a pair of 3s, so I'm going to cross one out, bring the other one out front. Same thing with the pair of 2s. Cross one out, bring one out front. Now, the number left over here is 2. Actually, I'm going to underline it. So 2 is a number that does not have a pair, so it's stuck under the radical. 6 root 2. Number 3, the square root of 21. If I break this down to 7 and 3, there are no pairs, so we already know that the square root of 21 is as simplified as it's going to get. Now, while simplifying the next ones, we have a number in front of our radical. So when we focus on the number inside the radical, this can break down to 5 and 25 can break down to 5 and 5. So there's already a number out front though, so that 4 has to multiply with our pair of 5s, and then there's a 5 left over into the radical. So 4 times 5 gets us 20 root 5. Number 5, we have 112. So we can break that down into 2 and 56. 56 breaks down into 8 and 7. 8 breaks to 2 and 4. 4 breaks to 2 and 2. So we have a pair of 2s and another pair of 2s. We also have a negative out front. So that means we have negative 1 times pair of 2 times pair of 2. Root 7 is the only number left over. So we would get negative 4 root 7. Our last one is 1/2 root 192. So 192, we can divide that into 2 and 96. 96 can break into 6 and 16. 6 can break to 2 and 3, and 16 can break to 4 and 4. So usually we need prime numbers, and we know that 4 is not a prime number. But if there's a pair of 4s, we don't have to make more work for ourselves. We can just use that number, and we have a pair of 2. So there's already a half out front multiplied by 2 and 4, root 3 left over. So we have 1/2 times 2 times 4, which gets us 4, root 3. Now, when we are multiplying radicals, remember that you want to multiply the outside by the outside and the inside by the inside. And then we're going to simplify if possible. So in number 1, when we multiply, we're going to have 3 times 4 and 5 times 2. So we have 3 times 4 root 5 times 2, which gets us 12 root 10. 10 can't be broken down any further, so that is as simplified as it gets. In number 2, on the outside we have 5 and then no number, so we're going to say that's a 1. And then we have 20 times 5. So when we multiply here, we have 5 times 1 root 20 times 5, which gets us 5 root 100. We know that 100 is a perfect square, and the square root of 100 is 10. So we have 5 times 10. Notice because it was a perfect square, the root is completely gone. And 5 times 10 gets us 50. In number 3, we have 1/3 root 9 times root 9. So we have the 1/3 and then just a 1 outside that would multiply together. And we have 9 times 9, which would multiply together. So 1/3 times 1 is 1/3. 9 times 9 gets us a square root of 81. 81 is a perfect square because remember we go back to 9 and 9, so that's really just 9. So we have 1/3 times 9, which is 3. Number 4, when we multiply on the outside, we have a 1/2 and a 1, and on the inside we have 6 times 12. So when we multiply those together, that gets us 1/2 the square root of 72. Now, 72 is not a perfect square, so we're going to need to break that down. Two numbers that multiply to 72 are 8 and 9. Two numbers that multiply to 8 are 4 and 2. Two numbers that multiply to 4 are 2 and 2. Two numbers that multiply to 9 are 3 and 3. Now that we are at our prime numbers, we have a group of 2 and a group of 3. So we're going to have 1/2 times 2 times 3, with this 2 left over under the root. So 1/2 times 2 times 3 is going to get us 3 root 2. In number 5, on the outside we have 7 times 3, and on the inside we have 8 times 3. So 7 times 3 is 21. And 8 times 3 is 24. Two numbers that multiply to 24, we can go back to 8 and 3, or I'm going to do 4 and 6. Two numbers that multiply to 4 are 2 and 2. Two numbers that multiply to 6 are 2 and 3. So we have a pair of 2's that are going to multiply with the 21. And we have a 2 and a 3 left over. So that gets us 42 root 6. In number 6, when we multiply, on the outside we have a 2 and a 1. And on the inside, we have a 36 and an 18. So when we multiply, 2 times 1 is 2. 36 times 18 is 648. So when we break this down, we can break it into 36 and 18 because those are the numbers we originally multiplied. 36 breaks to 6 and 6, so I can cut some of my work down and just use that as a group. I have to keep breaking down 18, though, into 9 and 2. 9 breaks to 3 and 3, so that's a pair of 3. So there's a 2 outside already, multiplies with a 6 and a 3 from our groups, and there's a 2 left over. So 2 times 6 times 3 is 36 root 2. So we know how to already factor tree to simplify square roots from the last unit. Now we're going to look at what happens when there are variables under the square root. If the exponent is even, you are just going to divide by 2, and there's no variable that remains under the radical. If the exponent is odd, you are going to subtract 1 and then divide by 2. So in this case, if we look at the examples here, we have f to the 6th power. Well, 6 is an even number, so we're just going to divide 6 in half, and we get f to the 3rd. There's no radical. W to the 11th, though, is an odd number, so one of them stays under, which changes that to a 10, and then we can split that 10 in half to get the 5 on the outside. So let's look at some examples. Number 1, t squared. So half of 2 is 1, and because it's an even number, there's nothing left under the radical. Now, in number 2, the square root of q to the 5th. This is an odd number, so we're going to have one of the q's underneath. So if I leave one q underneath the radical, I'm left with q to the 4th, and half of 4 gets us q squared. In number 3, we have 2 letters under the radical. So g is an odd number, so we're going to leave a g under the square root, change that to 4. Half of 4 gets us 2, so g to the 2nd power. F to the 8th. 8 is an even number, so we're going to cut 8 in half, and we get f to the 4th. Number 4, we have 3 letters, k to the 13th, j to the 12th, and g to the 17th. So we're going to go letter by letter. K is an odd, so 1k is going to stay under. That changes to 12, and half of 12 is 6, so on the outside we have k to the 6th. J is already an even with 12, so half of 12 gets us j to the 6th. Nothing is under the radical because it was even. G also has an odd exponent, so 1g is going to stay underneath, which drops this down to 16, and half of 16 gets us g to the 8th on the outside. Number 5, there's a number under the radical. Now, we know the square root of 49 is 7, so we just write 7 with no root. And then we have m to the 8th. Well, half of 8 is 4, and n to the 12th, half of 12 is 6. There's nothing under the radical because 49 is a perfect square, and m and n both had even exponents. Now, number 6. We already have a 5 there. We know the square root of 9 is 3, so 5 times 3. C is an odd number, so we're going to have a square root with c. This brings it down to an exponent of 14. Half of 14 is 7, so we have c to the 7th. And then f to the 6th, well, half of 6 is 3, so we can multiply 5 times 3, and we get 15, c to the 7th, f to the 3rd, square root c. Number 7, we have the square root of 24. So 24, we're going to have to factor tree. So 2 numbers that multiply to 24 are 6 and 4. 2 numbers that multiply to 6 are 3 and 2. 2 numbers that multiply to 4 are 2 and 2. So we have a pair of 2's that comes out front. Underneath the radical, we have the 3 and the 2 still. Then if we look at p to the 7th is an odd number. So one of the p's is going to stay under the radical. That changes this to a 6. Half of 6 gets us p to the 3rd. So we have 2p to the 3rd root 6p. Number 8, the square root of 40. Negative 9 times the square root of 40, p to the 7th. So 40 can break down to 4 and 10. 4 can break to 2 and 2. 10 can break to 2 and 5. So we have a pair of 2's. That's going to multiply with our 9 out front. In the radical, we're going to have a 2 and a 5 left over. Now, p to the 7th, again, is odd. So 1p will stay under the square root, which brings us down to 6. And then half of 6 gets us p to the 3rd. So we have negative 18, p to the 3rd, root 10p. Number 9, we have the square root of 128, d to the 23rd, f to the 28th, and g to the 17th. So first we're going to break down 128. So 128 can break down to 2 and 64. 64 can break to 8 and 8. That's our pair. And we have a 2 left under the radical. If we look at d to the 23rd, that's an odd exponent. So one of the d's has to stay under the square root. This brings it to 22. Half of 22 then is 11, so we get d to the 11th. F is an even exponent, so half of 28 is 14. And then we have g to the 17th, so 1g stays under the square root to make this an even exponent. Half of 16 then gets us g to the 8th. Let's look at one more. So if we look at number 11, the square root of 3 square root 270, a to the 8th, b to the 10th, and c to the 13th. So if we break down 270, that can break down to 27 and 10. 27 breaks down to 9 and 3. 9 breaks to 3 and 3. 10 breaks to 5 and 2. So we have a pair of 3s. Under 5 times 2. Then we look at each variable. So a is even, so half of 8 gets us a to the 4th. B is even, so half of 10 gets us 5. C is odd, so 1c is going to stay under the square root, which will bring this exponent to 12, and then we can cut that in half. So half of 12 is 6. So we get 9, a to the 4th, b to the 5th, c to the 6th, root 3 times 5 times 2 is 30c.